Recently, the James Webb Space Telescope spotted something that shouldn't even exist. It's a discovery that challenges everything we thought we knew about the universe. Let's dive into this mysterious object that's shaking up cosmic science. When we look up at the night sky, we're actually seeing light that left those stars long ago. Take the sun, for example. It's about 93 million miles from Earth, and its light takes 8 minutes and 20 seconds to reach us. So, we're always seeing the sun as it was 8 minutes ago. Now imagine a star like Proxima Centauri, our closest neighbor beyond the sun. Its light takes over 4 years to reach us, which means we're seeing it as it looked 4 years ago. Now, imagine galaxies so far away that their light takes millions, or even billions, of years to reach us. When we observe them, we're looking back in time, seeing them as they were ages ago. But that light doesn't arrive unchanged. Because the universe is expanding, the galaxies are moving away from us, and the farther they are, the faster they're retreating. Some galaxies are so far away that they're moving faster than light can easily catch up, all because of the universe's expansion. Light travels in waves, and when a galaxy moves away from us, those waves stretch out, shifting toward the red end of the spectrum. This is called redshift. The farther a galaxy is, the more redshifted its light becomes. By measuring this, scientists can figure out how far the light has traveled and how long ago it began its journey. But for extremely distant galaxies, the redshift is so intense that their light stretches all the way into the infrared. That's a type of light our eyes can't see. So how do we observe it? That's where the James Webb Space Telescope comes in. It's specially designed to detect infrared light, making it perfect for spotting galaxies from the very early universe. In other words, Webb lets us see what ancient galaxies looked like billions of years ago. So, how old is the universe? While there's still some debate, the most widely accepted estimate is around 13.8 billion years. That leads to a big question. What did the universe look like in its earliest days? Thanks to the James Webb Space Telescope, we now have a way to look back in time. As soon as Webb began its mission in 2022, scientists aimed it toward the most distant galaxies, hoping to catch a glimpse of the universe's first moments. And what they found was truly incredible. One of those galaxies was named JADES, GSZ13-1. The light from this galaxy took over 13.4 billion years to reach us. That means we're seeing it as it looked just 330 million years after the Big Bang, when the universe was only about 2% of its current age. But here's the mind-bending part. Because the universe has been expanding, this galaxy is now estimated to be about 33.4 billion light-years away. Wait, how is that possible? Well, even though light travels at a constant speed, the space between us and that galaxy has been stretching the whole time. So by the time the light got here, the galaxy had moved much farther away, because space itself has been expanding. So, when scientists saw this incredibly distant galaxy from the early universe, they were stunned. A galaxy already formed, just 330 million years after the Big Bang. But what is a galaxy exactly? It's a massive system of stars, planets, gas, and dust, all held together by gravity. Our own solar system is just one tiny part of the Milky Way galaxy, and each galaxy can contain anywhere from millions to trillions of stars like our sun. Because of that, scientists had assumed that forming a full galaxy would take a lot of time. But this wasn't just a single star or a gas cloud. It was a full-fledged galaxy, already made up of tens of millions of stars. That means galaxies may have formed much earlier and much faster than we ever imagined. This galaxy existed when the universe was just 2% of its current age. So what was the universe like back then? That era was known as the Epic of Reanization, a major turning point in cosmic history. Right after the Big Bang, the universe was a hot soup of plasma. There were no atoms, just free-floating protons and electrons. Light couldn't travel freely because it kept bouncing off these charged particles. Then, around 380,000 years later, the universe cooled down enough for protons and electrons to combine, forming neutral hydrogen atoms. These atoms absorbed light, making the universe dark. But as the first stars formed, they began emitting ultraviolet light. That energy started breaking apart the neutral hydrogen, a process called reionization. It marked the moment when the universe began to light up again. For about 1 billion years after the Big Bang, the universe was still in the process of reionization. During this time, ultraviolet light couldn't travel freely. The universe was still mostly opaque. So, any UV light coming from a galaxy 330 million years after the Big Bang should have been absorbed before it could reach us. But here's the twist. The James Webb Space Telescope detected UV light from that galaxy. Wait, doesn't Webb observe infrared, not ultraviolet? Exactly. So how did it see ultraviolet light? Remember redshift? The galaxy originally emitted ultraviolet light, but as that light traveled through the expanding universe, its wavelength stretched all the way into the infrared range. Webb picked up that light as infrared. Then, using calculations, scientists figured out that it originally started as ultraviolet. In this galaxy's light, scientists detected a very specific signal, a bright hydrogen emission line known as the Lyman alpha line. This type of light appears when a hydrogen atom gets energized. It releases a strong, distinct burst of ultraviolet light. But here's the strange part. Back then, the universe was still filled with a thick fog of neutral hydrogen gas. That gas should have absorbed any Lyman alpha light, making it nearly impossible to detect. And yet, Webb saw it clearly. This galaxy existed just 330 million years after the Big Bang, long before that cosmic fog was expected to clear. But somehow, it was already shining through with a sharp, unmistakable Lyman alpha signal. In the end, this discovery suggests that reionization may have started much earlier than we thought. In other words, stars and galaxies must have formed faster and sooner than expected, quickly ionizing the neutral hydrogen around them. Our picture of the early universe is changing. The universe doesn't speak. It makes no sound and offers no reply. And yet, in its silence, it's always telling us something. Through time and space, the cosmos sends a message, and scientists are still listening. Hope you enjoyed today's journey. We'll be back soon with another story from the universe.